Hi everyone, we'll be starting our next topic of electrolytic conductance. The next topic is electrolytic conductance. I think most of the topics are being covered in your physics also. This is just the revision. I'll not be explaining it in too detail because this is like just a short topic. So first thing is you need to understand the difference between metallic conductance and your electrolytic conductance. You know what is conductance, right? Flow of current. Whatever is having flow of electrons easily, that will have a very good that will deliver very good electricity, right? And there is some difference in electrolytic conductance. What is conductance? Like it is allowing you to have a flow of electrons, or it allows you to conduct electricity. That's why you have conductors and insulators, right? Now what is metallic conductance? The current here is flowing due to flow of electrons. Current is flowing due to your flow of electrons. And what is electrolytic conductance? You must be remembering in your cell, electrolytic cells and all, and Daniel cell. Here the current flows due to flow of ions. Current is flowing due to flow of ions. Okay. The second point is there is no chemical decomposition of substance. You must be seeing that whatever metals we are seeing as conductors, there is no chemical decomposition. There is no chemical decomposition of substance using current. And here what happens is there is a chemical decomposition, right? There is a chemical decomposition using current. The chemical decomposition happens using the current. The third point is the resistance. Resistance means hindrance to the current, right? The resistance is due to collision of kernel. What is a kernel? That positive part. So resistance is basically due to the collision of your kernels here. And here you'll have a lot of resistance. Resistance will be due to interactions. Interactions between whom? Let us study. Resistance will be due to interaction between resistance is due to interaction between your solute. So there can be your solute interactions as well as your solute solvent interaction. What is solvent? Solvent can be water and all. Solute solvent interaction. And third kind of resistance can be because of solvent interaction. Solute solvent, or solvent interaction. Okay. Then fourth point is resistance increases on increasing temperature. The current will not flow on increasing the temperature, like it will have difficulty in flowing. So resistance increases on increasing the temperature, and here your resistance decreases on increasing temperature. This is very important point. Resistance will decrease on increasing the temperature. And why this happens? Because as your energy increases, as your energy is increasing on increasing the temperature, right, the interaction level will decrease. Why? So interaction is decreasing between solute, solvent, solute. So because of that decreased interaction, your resistance will decrease, and if resistance is decreasing, definitely your conductance will increase. So now here we saw a few things of metallic conductance as well as electrolytic conductance. In metallic conductance, the current flow is due to flow of electrons. In electrolytic conductance, the current flow is due to flow of ions. There is no chemical decomposition. There is a chemical decomposition. Third thing is resistance is due to the kernel, and here the resistance is due to the interaction between particles. More interactions, more resistance. So how do we break that interaction? We break that interaction by increasing the temperature so that your conductance increases. Okay. Now we will do some general terms related to this conductance topic. First is your resistance. Resistance. What is resistance? Anything which resists the current, right? Which is not allowing the current to flow. It is represented by R and its unit is ohm. The unit is OHM, ohm. This is how you represent the unit. Resistance means hindrance to the current, hindrance to the flow of current. The second one is your conductance. That's just the opposite of resistance is your conductance. What is conductance? Opposite of R, right? So you'll just mention it as C equals to 1 by R. And the unit will also be opposite. Unit will be ohm inverse. You'll write it down like this, ohm inverse, or MHO, mho, or your Siemens. Ohm inverse, mho, or Siemens, which is represented by S. This is what your conductance is. And both are inversely proportional, right? The third thing which you need to remember is specific resistance or resistivity. Both are same thing only. Specific resistance we call it. Specific resistance or your resistivity. Both are same things. Now what is this actually? Just remember the formula of resistance. One more formula we have for resistance. R is equal to your rho L upon A. How does this formula come? Sorry. Specific resistance or resistivity. See, for this you need to remember R is directly proportional to your length of the container and inversely proportional to your area of container. The resistance, we are not talking about specific resistance or your resistivity. We are talking about resistance. Resistance here is directly proportional to your L upon A. Now, if we want to remove the proportionality sign, we need to keep a constant, right? This constant is called rho. This constant is called your rho. So if we just cross multiply things, we'll get rho is equal to RA upon L. This rho is called as your specific resistance or your resistivity. This rho is called, this is called as rho, okay? Rho is called as your specific resistance or your specificity, resistivity. Now, if I take my area as 1 centimeter square is my area. If I am taking area as my 1 centimeter square, and if I am taking my length as 1 centimeter. If I am taking my area as 1 centimeter and my length as 1 centimeter, what will be the volume? Volume is calculated by the formula area into length, which is equal to your 1 centimeter square into 1 centimeter, which will be equal to 1 centimeter cube. 1 centimeter cube is equal to your 1 ml. Now, if I place this both values here, then my rho equals to R, right? So, according to the formula, the definition will be resistivity is the resistance to all ions. Resistivity is the resistance of all ions of electrolyte present in 1 ml of solution. Present in 1 ml of solution. You are taking a cube, for example. One centimeter square you are taking this. 1 centimeter square you are taking the area, 1 centimeter you are taking the length. So whatever ions are present in between this area, like 1 ml area, that ion, those ions, whatever resistance they are facing, that is called as your resistivity. Okay, that electrolyte between this area, those ions, whatever resistance they face, that is called as your specific resistance or your resistivity, represented by rho. And what will be its unit? Rho is equals to R A by R. What is the unit of R? R is your ohm, right? So ohm into centimeter square by centimeter. Like just substitute the units of all this thing. What will you get? Centimeter get cancelled, so your unit will be ohm centimeter. So three things we have now known. Resistance, it's the hindrance to the current. R represented by ohm, and you mention it by a symbol like this. Then you have conductance. Conductance is just the opposite of resistance, 1 upon R. Okay, then we have studied about specific resistance or your resistivity. It is the resistance of ions which are present in 1 centimeter square area and 1 centimeter length. That is your specific resistance, and its unit is ohm centimeter. Okay, this is your specific resistance or resistivity. Next thing, fourth thing which you have to remember is conductivity. I think this is fourth. Yeah. Fourth thing which you have to remember is conductivity. Resistivity we have learned. What is conductivity now? Conductivity is mentioned by a symbol called as, it's written as a K fashion, in a K fashion, and this thing is called as kappa. It's called as kappa. This conductivity is also called as specific conductance. You can write it as conductivity or specific conductance. The previous one was specific resistance or resistivity. This is your conductivity or specific conductance. And what is the specific conductance? Just the opposite of resistivity. So your kappa will be equal to your 1 upon rho. What was rho? We had studied. Rho was equal to your R into A divided by L, right? Substitute this here. What will you get? Kappa equals to 1 upon R into A into L. That's your kappa. Now if I just want to just separate it and write 1 upon R into L upon A. This is your conductance, right? 1 upon R is your conductance. If I am not wrong, this is your conductance. And this is L upon A is called as cell constant. L upon A is called as cell constant because it's constant for a cell, right? So cell constant. So you can also mention kappa as conductance into your cell constant. Conductance into your cell constant. That's your conductivity or specific conductance. Okay. So what is actually kappa? Conductance due to all ions present in conductance. This is your conductance due to all ions present in 1 centimeter cube area or 1 ml area. And what will be the unit? Just substitute the units here. What was the unit of resistance? Resistance was ohm. Liter is centimeter, and here you have square. So 1 minus 2 minus 1. So the unit will be ohm inverse centimeter inverse. Ohm inverse is also called as mho, right? Mho or centimeter inverse. This might be also called as Siemens centimeter inverse. Okay. So all these things we have studied now. Next is molar conductivity and your equivalent conductivity. Very important topic, but before that let's revise the 4 things which we have studied now. because the molar conductivity and equivalent conductivity are related to your these four topics only. So just a quick revision. First thing we studied was about resistance. What is resistance? The hindrance to the current, right? It is represented by R, or ohm is the unit. Second thing which we studied was conductance. What was conductance? The opposite of resistance. It is represented as 1 upon R. The unit is ohm, ohm inverse, mho or Siemens. The third thing which we studied was specific resistance or resistivity. Specific resistance, which is also called as resistivity. It's represented by rho. Rho is equals to 1 upon R into L upon A. I think R will come above, right? This is kappa. Okay. This is equal to your R into L upon A. And what will be the unit? The unit will be ohm centimeter. It's actually showing the resistance between it's showing the resistance between 1 centimeter square area and 1 centimeter distance, like resistance of all the ions present in 1 ml of your electrolyte. Next is your specific conductance. Specific conductance or conductivity, just the opposite. It is represented by kappa. So kappa will be equal to 1 upon R into L upon A. Just do this opposite. Resistivity, so it's actually the conductance between 1 centimeter cube ions. Just the opposite units. Okay, so these four are the major things. Then what you have to keep in mind, the fifth thing is your molar conductivity. Fifth thing is your molar conductivity. Now, by definition, what does this mean? By definition, it means conductance due to all ions. Conductance due to all ions of that volume of electrolyte, of all ions due to that volume of electrolyte which contains 1 mole of electrolyte. Which contains 1 mole of electrolyte. So what is molar conductivity? Conductance due to all ions of that volume of electrolyte which contains 1 mole of electrolyte. Now, why was this term basically introduced? Suppose I asked Sam how much is the conductivity of NaCl. So he told, okay, this might be 5. Sam is reporting 5. Sam is reporting 5. The other person, Y person, is telling no, there's conductivity of NaCl is 500. Why? Because maybe it might have happened that this one is in major concentration, like your concentration, the number of ions might be more. So that's why molar conductivity will give us the equal values, because the concentration of both the things will be same, which contains 1 mole of electrolyte, right? And what will be the formula? It is represented as this, in this fashion. So molar conductivity will be equal to your kappa into volume. Kappa into volume. Okay, now we already know that molarity, what is molarity? Moles of solute dissolved in a liter of solution. Now if I'm telling n, let's say n equals to 1, what is molarity in liters? 1 upon V, right? So V in liters will be equal to 1 upon m, correct? Now same way, if I want to do volume in milliliters or centimeter cube, what will I do? Volume in liters need to be multiplied by 1000, right? That's what I am doing here. Volume in liter is 1 upon m into 1000. 1 upon m into 1000. Volume in ml. If I want to take ml or say centimeter cube, both are same. Just substitute this thing here. Your lambda m will be getting the value kappa into 1000 by m. Kappa into 1000 by m. That's your formula. Molar conductivity formula is conductance due to all the ions present in 1 mole of electrolyte. And what will be the unit? What is the unit of kappa? Siemens centimeter inverse. And here your molarity unit is mole upon centimeter cube. Solve it, the unit will be Siemens centimeter square mole inverse. That is your molar conductivity. Similar to this, you will have the next term as equivalent conductivity. What is equivalent conductivity? By definition, conductance, same thing, only just replace with equivalent. Due to all ions, conductance due to all ions present in that volume of solution which contains 1 gram equivalent of electrolyte. So instead of taking 1 mole of electrolyte, we are taking here 1 gram equivalent of electrolyte. Instead of taking 1 mole, we are taking 1 gram equivalent of electrolyte. And what will be the formula? Lambda equals to kappa into V. Same thing. But here, you know 1 gram equivalent we are taking, right? So normality equals to number of gram equivalent upon volume. Number of gram equivalent upon volume in liters. Now suppose number of gram equivalent is 1. So N equals to 1 upon volume in liters. If I want to do volume in milliliters here, what do I have to do? 1 upon N into 1000. Same thing here, just substitute here. What will you get? Lambda E equals, not lambda, actually this is called equivalent conductivity, equals to kappa into 1000 by N. Kappa into 1000 by N. So this is all about your molar conductivity and your equivalent conductivity. The conductivity of all the ions present in 1 gram equivalent of electrolyte in that particular area. That's called as equivalent conductivity. So what did we study? We studied about first resistance. What is the, I am not writing the units now. The resistance is R and it doesn't have any formula as such, but you can just tell 1 by C. Second thing which we studied was conductance. What is conductance? Conductance is represented by C, which is equal to your 1 upon R. Then we studied about specific conductance. Okay, specific resistance will take first. Specific resistance or resistivity. It is represented by rho. And your rho equals to R into L by A. Then fourth thing we studied was specific conductance. specific conductance or conductivity. We can mention it as kappa. Kappa equals to 1 upon R into L upon A. Specific conductance is the conductivity of all the ions present in whatever thing. This is the resistance and this is the conductance. Then fifth thing we studied was molar conductivity. Molar conductivity, this we represented by the formula lambda E, and lambda equals to kappa into 1000 by N. It is the conductivity of all the ions which are present in 1 mole. And similarly we studied about equivalent conductivity. Which is represented as lambda, this is lambda M, this is your lambda E, and lambda E will be equal to lambda E will be equal to kappa into 1000 by N, normality. So these are the formulas which you need to remember. You can take a screenshot of this for your ease. And let's do the questions now. 2-3 questions we'll do, and then we'll do the variations of conductivity. Okay, the first question is telling you, for your 0.01 N NaCl solution, your R is equal to your 200 ohm. R is equal to your 200 ohm at your 25 degrees Celsius. If your cell constant is unity means 1. Calculate the equivalent conductivity. Okay, so we need to calculate equivalent conductivity. We know the formula, kappa into 1000 by N, right? And they've already given us, everything is already given. We need to find lambda E, kappa. What was kappa? Conductivity, right? Kappa was your conductivity. So conductivity was 1 upon R into L upon A, into 1000. This full divide by N. L upon A, they have already told us this is unity. So 1 upon 200 into 1000 by 0.01. What is 0.01? You can write it as 1 into 100. Now when you solve this thing, you will be getting 500. Just write the units, Siemens centimeter square Q minus 1. Just directly substitute the values. You now know all the formulas, so this thing will be comparatively very easy for you. Okay. Now second question. Second question is telling you, for a decinormal solution, you need to understand what is decinormal. Decinormal means n by 10. Decinormal solution, resistance of electrolyte is. Resistance of electrolyte is 32 ohm. If your distance between electrode, if the distance between electrode is 1.8 centimeter, and area of electrode and what is the area of electrode? 5.4 centimeter square. You need to calculate certain things. You need to calculate firstly the cell constant. Try this on your own. Cell constant. Second thing which you need to find is specific conductance and equivalent conductivity. Everything is formula based. Specific conductance, and third thing which you need to find is equivalent conductivity. Equivalent conductivity. Now you know cell constant was equal to your L by A, right? First thing is we need to find cell constant. Cell constant was L by A. Simply divide it. 1.8 divided by 5.4. 18, 16, 24. So you will be getting 0.33 centimeter inverse. That will be your this thing. Second thing which you need to find is specific conductance. What is specific conductance? Conductivity, which is your kappa. Kappa is your 1 upon R into L by A. Now L by A you already know. 1 upon R is given to you 32 into 0.33. Just apply this formula. Cell constant 1 upon R into L upon A. Yeah, just apply this formula and check what will be the answer. Just simply need to solve. The third one, you need to find equivalent conductivity. Equivalent conductivity was specific conductance, conductivity, equivalent conductivity, lambda E. Lambda E was kappa into 1000 by N. Decinormal. Decinormal means N by 10, 1 by 10. Kappa we already know from here, 1.32 into 0.33 into 1000 divided by 1 by 10. 1 by 10 you can directly write it as 0.1 also. After solving it you will get the answer. Okay, easy, right? Just formula based question comes most of the times. Next topic which we need to cover is relation between lambda E, like equivalent conductivity, and molar conductivity. How do we find relations between them? Just divide them. Lambda M by lambda E. What was lambda M? Kappa into 1000 by M, and this is actually divided by kappa into 1000 by N. Lambda M by lambda. This is not lambda, I'm just pronouncing it as lambda. You cancel everything. What is remaining? N by M. What is N? Number of gram equivalent by volume. Number of gram equivalent by volume, and this will be number of moles divided by volume. Volume and volume gets cancelled. What is remaining? Number of gram equivalent by number of moles. Number of gram equivalent is mass given by equivalent mass. And number of moles is mass given by molar mass. Mass given by molar mass. Mass given gets cancelled. What do you get? Molar mass by equivalent mass, right? Equivalent mass is molar mass divided by X. This is molar mass divided by X. So this and this get cancelled. This X comes above. So XM by X, lambda E will be equal to your X. This you need to remember. Lambda M by lambda E will be equal to your X. So X can be anything, okay? Number of ionizable H plus ions or positive ions. Like in acids, if you are taking H plus, it's 1. OH minus, it's 1. If you are taking H2SO4, here H plus you will get as 2. That's what your X is. Okay. Then okay, next very important topic, we'll do it in the next video, and Colroach law is also remaining. I think we'll continue in the next video. Till now, please revise all these formulas and practice as many questions as you can. Thank you so much.